Hello, everyone, and welcome to our June edition of VJUG Live. For those of you who don't know me, which is probably most of you, I am Sam Hepburn. I am one of the co-organizers of the virtual Java user group, and I'm really excited to be here with you again today. I'd love to know where everyone's watching from. So if you're watching, please pop in the comments on YouTube where you're dialing in from in the world. I'm personally based in London. It's a nice sunny day. Although the accent is from South Africa, if that throws you off. But yeah, tell me where you are dialing in from. So welcome to the virtual Java user group. We're a global community bringing together high quality tech talks and speakers from all around the world. Yeah, we like to collaborate with other Java user groups. So if you see any of our VJUG Connect events, we like to live stream Java user groups from all over the world. So if you are watching and you do have a local Java user group and you'd love to see your content on our platform, please let us know. It means that you can watch sessions from everywhere. It doesn't matter where you are. But today our session is going to be with an amazing speaker named Aicha. But before I invite her, as well as Micah Silverman, our epic host, to the stage, I just want to remind everyone that we have a great Slack community. So if you're not part of our Slack community, please join us. This is a great place. We'll also be monitoring the Slack for questions, but pop them in the YouTube chat as well. But if you don't have a YouTube account that allows for questions, pop them in Slack and I'll get them over to Aicha as well. And then after the sessions, all of our speakers are also part of our Slack community. So if you've watched any of our past events, if you're rewatching this event after the live stream, pop into the Slack community and you can ask any questions. We also have other giveaways, free conferencing tickets, a whole bunch of stuff to get involved in. So check that out. And if you want to come to any of our other events, if you go to our meetup, our virtual JUG meetup page, you'll be able to see all our upcoming sessions. But that's enough blabber from me. Let's bring my lovely friend Micah to the stage. Micah, welcome to VJUG.
Hello. So good to be here with everybody today. It's a treat.
Awesome. So Mike and I are actually past colleagues. So I'm very excited to be on stage with him because I haven't seen him in over a year.
Too long.
Far too long.
Yeah.
Nice, Micah. Are you looking forward to the session as much as I am?
I so am.
Amazing.
I can't believe I missed Aicha at JCon, but I'm tickled that we're both wearing our JCon shirts today, and we did not collude or plan that, so we'll see that in a moment.
I'm going to need a JCon shirt, so I can also fit in. Amazing. Well, should we bring Aicha to the stage?
Yes, let's do.
Hi, Aicha.
Hello, everyone. Hi.
Well, I'm going to need Aicha and Micah to take it on, but I will be backstage and I'll see you all at the end of the session.
Right. Thank you so much, Sam. Welcome, Aicha. I'm really excited for this talk. I've written down a few questions of my own, but I'm sure we'll get a bunch from others. But why don't you take it away? I will remove myself. I'm very excited to hear you speak today about building sustainable software with Java, tips and techniques.
Well, thank you for having me. I'm really happy because I got from watching this virtual jog session each month into being like a host or speaking. It's a really pleasure here. So today's session is special and I want all your attention to be on mine because I'll give you all you need to know about sustainable software in Java. And also, I'd like to ask if you have any question, feel free to ask or to interact with me during my talk. If you didn't have, you are curious about one point, you want more clarity, you want even to have more tips to share. It's like interaction, then more just a monologue for me to talk. And now, let's start our session officially. But before let me introduce myself, my name is Aicha Laafia. I am a Java software engineer at Havana Group. Originally, I'm Moroccan. Right now, I'm in Morocco in vacation, but currently, I'm living in France. And beside my work as Java engineer, I'm passionate about green programming, Java ecosystem, sustainability, and Women in Tech, and that's why I'm Women Techmakers ambassador and Girls Code. I'm always trying to advocating to have more women in our field. And also because I believe sharing is caring, I always try to share my knowledge, whatever it's a small info or a big one, new one. And this is why I'm part of many communities, many like initiatives such as JetBrain Community Contributors and the Moroccan Association for Computing Science. Well, fun facts about me, I'm a foodie lover and a big Formula One fan. And this is alert you will have a few like Formula One terms or memes during this session. I also write from time to time about Java, scalability, or even like mental health in our tech industry. In my Medium blogs, you can check that later. And now the most big 1 million question you might want to ask yourself, why you are attending this talk? Why am I giving this talk? Why sustainability matters? Well, you have to know one thing. Our applications, our code are not just bits and bytes running on the background, but every inefficient line of code, every like character you type has a real impact on the environment. For example, our tech industry like consumes 7% of the global electricity. In data centers alone, like consumes 2% of that, and that's more than some entire country's electricity. And by the like the trends, the AI, it's even like needing more energy because every prompt you write need a huge amount to get you the result you want. And also there is something more important than energy, which is the carbon emissions. Unfortunately, our tech industry produces 4% of the global greenhouse gas emissions. And that's, you can say, like equivalent to the double of the carbon emission that the airline industry produced. That's 2%. So every inefficient line of code we write, every application we have, like we can say it produces a CO2. And if you are thinking maybe those like big numbers, huge numbers are related to the data centers, the biggest projects, well, that's totally wrong because sometimes even the smallest activities we do in our daily life contribute to that. For example, you like watching your favorite show on your favorite streaming like website or application. If you stream it only for 1 hour, you produce between 55 gram to 100 gram of CO2. And something we do like whatever it's personal or professional, we send emails. So if you send 20 emails per day for 1 year, that's equivalent to driving 1,000 kilometer in the road. So as you can see, whatever we're talking about, the big scale or the daily tasks, every inefficient line of code that have been written in this application has impacts on the environment. And what you can do about it, this is where we'll introduce like green programming. But first, I want to ask you like, what do you think or what's the first thing come in your mind when you hear green programming? Like what's the words that pop up in your mind? I really want to see like in the comments, what do you think about this? Like what the idea that you visualize about this? Do you visualize energy? Do you visualize green or even planets? Like I'm really curious to know that. So because normally this is the main topic I'm going to talk about, green programming. And that's only like specified for Java, but all the terms I'm going to say here, it could be used in other language too. And yes,
Aisha, we have a
efficient,
couple of comments. One is efficient code. Maybe you saw that. And minimum resources on cloud.
yes,
I kind of think of it as, I feel a little guilty every time I do a search on Perplexity, for instance. Like, what energy is being consumed just doing a search, let alone programming?
indeed.
Caring
And
about
actually,
CPU cycles.
yes. And that's all correct, actually, because normally during programming, yes, during programming, it's in what does mean it's involving like developing software with the focus on what all you said. It's about energy efficiency and sustainability. That means writing code that uses less power, optimizing our application to run more efficiently, and the most important thing is considering the environmental impact of our development choices. Every line of code, every algorithm we use, you need to know that it has an impact. And not only talking about the financial one, about the like the bills, about the gains that our application could produce, but also the CO2 that could produce too. And by that, we need to introduce strategies for green Java development. And as a Java developer, the first thing or the first area we need to impact is, of course, the GVM, because this is like what makes Java special. And from this menu, you can guess the first step we need to talk about is garbage collection. Yes, because your virtual garbage matters too. We always talk about we need to protect the environment. We need to like making sure that our garbage being selected in the good way, being recycled. But what about the virtual ones too? Because garbage collection is not just about the memory management, but it directly impacts the CPU load, latency, and energy consumption. And in the world of green Java application, we want to minimize that impact as much as possible. So first thing, we need to choose the right garbage collection. And you might want to ask yourself is like which one, how I can do that. Well, it depends on your use case. For example, we have the G1 GC, which is the default choice for a reason, because it's balanced for large heaps, keep body sign low, and like one of the good things about keeping up with the latest Java version, like GDKs, in our production, in our application, is that if you use GDK 21 or the latest, like starting from 21, you have the G1 GC by default. You don't need to do anything, it's already there. And now you wanna like advance your gaming, have something a little bit you can say fancier. We have the ZGC, which is like low latency. It's best for real-time application where we cannot afford long pauses. And there is the more advanced, which is Shenandoah. I love it because it's concurrent compilation, it's great for scalable application, and the most important thing, it doesn't care about your memory size, whatever, it's 2 megabytes, 2 gigabytes, always making sure you have the lowest body stock. And if you don't care really about how long your pauses are, but you want something more high throughput, especially we're talking about the batches, like job batches, where there is parallel GC, it's really good with that. And finally, if you want only for testing ARKit or bitch banking testing, you want something that doesn't have any garbage collection mechanism or algorithms, we have Epsilon. And if you use this on your production, it will crash and you will end up like this guy here. So don't do that. So when right now, let's say you choose like your right garbage collection, but it's still like you have, we can say your application are still running slow and you don't know what's going on, even for the simple example, like here. So in this simple code, we only try to create 10 million transactions. Like each transaction has a random amount and a unique ID. And when we try to run it, it takes over 20 seconds. And that's too slow, right? So we need to investigate. And since we're only creating objects, let's say maybe it could be the garbage collection is the culprit, and how to investigate this. Good thing for us, we don't need any external like libraries because Java already provides built-in garbage collection login, which can help us see what's going on or what's happening under the hood. Like how often the garbage collection run and how long it takes, simply by running like our application will add in like some like minus x log here, and you need to specify which garbage collection you need, for example, to analyze. In our case, I'm telling them you need to like log all the garbage collection events to check the deposit sign. And also, if you want like to really to prevent dynamic expansion, you can add the minus xmx2g in the minus xms2g. It's to set the heap memory to 2 giga fixed. That's something I like to add to not really, I like to keep the things light for my machine instead of just let it go. And this is one of the principle of the green programming. Sometimes you don't let like the default setting or the machine do its work without measuring or without controlling in getting only the resources that you want. And now let's back. So when we run our application with this, like here, you will get all the logs like this. So as you can see, we have three types or three garbage collection running, the G10, the GC1, and the GC2. And they are all G1 GC because I'm already been using like GDK 24, so it's already there. And because it's too much to read, I try to recap for you. So I try to sum the long posit sign for each GC. And as you can see, like the posit, it's over the average of it, it's over 200 milliseconds. And these posits are only keeping up, slowing down our transaction processing. So right now we get to make sure that yes, garbage collection do its works, but it's already like making our application a little bit slow. And now, what we can do about this, like how we can prevent this. Sometimes it's easier. Sometimes it's just we need to tell our GVM we know like what we need and we need to specify it. And this is where we're talking about tuning garbage collection. Because instead of relying on the GVM default options, we need to specify what we need. So for example, here we have the minus xx past u c posit millis to 50. This is where we reduce the target posit time to like 50 millisecond. We have the minus xxg1 here for region size to 8M. Here we are telling the GVM to optimize the memory region size. We have like the minus xx initiating heap occupation, sorry, occupancy percent. It's happening. So we're telling to 30%, and this helped to trigger the GC earlier to prevent long pauses. And we have like the final one, which is the minus XXG1 mixed GC count target. This is kind of clear because from its name, you can know it limits the mixed GC events for better efficiency. When we run it, as a result, we get our execution time drop from 20.4 per second to almost like 12.7 seconds. And this is what the GC tuning is all about. It's about reducing pauses, improving stability, and always like optimizing memory. So what we learned from this is that tuning garbage collection can boost performance and save energy instead of just leaving the GVM's default setting. And now we have seen like the first strategy, which is the garbage collection or the GVM like tuning.
Aisha,
Yes. Do you
can I
have any
pop in a
question?
quick question here? Yeah, I think it's related, and maybe it's, you're going to cover more of this coming up, but we have this question. Is there a way to show, is there some sort of profile to show an environmental impact, or is it just like, execution times kind of translates directly to energy usage, that kind of thing?
Actually, yes. Normally for this, we're gonna see it later, but we measure the impact of it. Like we measure how much energy our application, our code consumes, how much carbon our application have been producing during that time, and by how like code really have an impact. We cannot have it directly. Like for example, this line of code has this impact on the environment because it's the overall applications. But as we can say, baby steps produce the biggest one. So even starting small can really help with the good green basic to build up a sustainable one.
Awesome. Great. Carry on.
Thank you. So as I said, even like garbage collection tuning isn't enough. Sometimes it's not just the memory, but the method execution itself can slowing us down. And this is where we call just in time to the rescue because instead of execution methods every time, just in time compiles frequently used method at the runtime because this is mean like faster execution, less CPU overheat, and lower memory usage. And this is why I said that we cannot really measure the impacts of one line because we have a mechanism that help us like optimizing our applications such as just-in-time compilation that use key optimization like inlining, escape analyze, and loop enrolling. That really has like impacts on our codes. For example, inlining like where just in time replace the method call with the direct code execution, cutting down like the method lookup time. And for the loop enrolling, instead of just going through all the loop, it reduces the number of the loop iteration, making the CPU cycle more efficient. Like we go through only the exact numbers of iteration we need. And this is why we cannot know, like, if we write a code, we said, oh, it's going to go through all the loop when actually it could like less numbers and less energy consumes. Also, like for escape analyze, the last one in my favorite because it helps avoid unnecessary heap allocation when we don't need to like we don't need to save or to have our like data and the heap escape analyze just keep it on the stack. And this is what I'm going to see later on the next slide. But like for me, in recap, just in time, I consider it as a formula pit crew, but with a twist. I'm not going to say it's crazy, but just in time compilation, it's really like a Formula One pit crew, but working during the race, like constantly fine tuning the car during the race, reducing like the pit stop time. This is exactly what just-in-time compilation do in maximizing speed on the track. So as I said, the example I'm going to talk about just-in-time compilation is escape analyze. Here, like our initial code that has create 1 million transactions this time, each transaction has like an ID, string reference, and double amount. And because of this string reference, it's right now like it's forced to the garbage collection to save it on the stack. Like, so what you gonna do about this? Well, right now, just in-time compilation can do nothing. So we don't see them, we don't think about this 1 million transactions, but they are being stored in memory even when we don't need them to be. What we can do about this, since string reference is already the issue, we need simply to remove it and keep only int and double. So right now, since we keep only the primitive types, just-in-time compilation said, okay, I got you, and like replace all that 1 million transaction on the stack. And that means no garbage collect, like no GC needed, no need to call it. And that means no long process time or anything. And also no like the CPU, no memory additionally used. And by this, we can optimize our resources. And also one thing that I changed it here to have more efficient, greener, which is, as you can see, before I used to have the virtual thread, because yes, I know virtual threads are cool, are something like we were happy about this that help us with like concurrency, with the working on parallel programming, parallel execution, but virtual threads has a price, which is waiting time. It has a long waiting time between each transaction. What you can do about this, we have the structured task because structured task scope improving concurrency It doesn't have that much long process time. So my advice to you, in, see your program. If it's simple, if it's, for example, we are talking about monolithic, simple service, don't use virtual tree. If you are only working with something related to, for example, mathematics, to equations, doesn't like it has input, simple input in output, don't use virtual tree. Use structured tree, or sometimes even the mono tree, the traditional one, are more efficient than the virtual one. But if you are using something like microservices, a lot of complex that need to call many different services or many different like resources at the same time, this is where we can use the virtual tree. And as you can see right now, since we're already like optimizing we have been tuning our GC poses, we have letting, we're helping just-in-time compilation do its work to optimize our resources. It's time to see those resources, where they went, where they go, because even the fastest code can be wasteful if it's burned through resource unnecessary. And right now I want to say like, do you analyze your resources from time to time? What tools you use? What strategy you use? Because I want to read your comments about this. And also like, you need, sometimes my advice to every developer, to consider yourself as a really, as that Formula One fan, because as a Formula One fan, I'm always like passionate about how those Formula One engineer always making track of the speed, like the resource being used there in the car in every moment, in every second. They always have metrics for that. And we have to do the same for our resources. We need to see where our resources are going, where our resources have been used, where exactly they have been used. Is there any leakage? And also you need to check the, you can say like the tools for that. So I would love to know if there are any other tools. Yes, because performance profiling also can be good during for, but that's not enough. So anyone, what's your tips for analyzing your resources? Or do you analyze your resources? Okay. So yes, someone said that they do always performance profiling, but never really focus on energy before. And yes, that's exactly profile. Okay, yeah. I'm reading something that's really good. There are some people saying they use profiler, they use UKit, GProfiler. That's something cool. You're already on like the good way, the good road for greener Java application. Actually, you are almost close to what I'm going to say, because that's exactly what, like what's in the slide. Because when analyzing resource usage, we need to focus on three key areas. It's about monitoring, identifying resource intense operation, and using advanced tools for deeper insights. Like to optimize efficiently, we first need visibility into what's happening at runtime. We're talking about the CPU, memory in our application, like how much our application is using. Are there any memory leaks? Are the GC adding unnecessary like heat over profiling? Are we really like running our application more efficiently, or just wasting energy without knowing that? So for this, we need to use tools like gconsole, visual VM, Java Machine Control to help us monitor performance in real life and catch, for example, potential bottlenecks before they could impact the user. So yes, monitoring profile like performance is a good start already. Also, we need to know that not all the operations are equal. Some are CPU heavy, some stress memory, and some drain power. So how we do pinpoint expensive one? And here's the issue, because we don't need to guess or just go randomly test all our code. but we need to use tools such as like the Java microbranch harness GMH, because with the GMH we can isolate specific method and measure their impacts instead of guessing. We got precise benchmark that tell us where to optimize. And this is like this tool can help you know the impact of parts of your code, as someone asked before. Can help give you a small insights into how much like your code really impact the environment by giving you numbers, showing you like how much resource that it drains. And also like for deeper insights, especially into memory and garbage collection behavior, we need to go beyond the basic monitoring because yes, we rely on just-in-time compilation. We rely on garbage collection for the memory. But what if even those mechanisms are not working correctly? So we need to like pay attention to them too. And this is where tools like gprofiler, ukit, and Eclipse MIT, and even like if you are using GraalVM, that's really good because it have a monitoring for all that too. It could easily analyze like the heap dump, identify the memory leaks, and fine-tune like the GC strategies that could help you. And you could like go beyond the basic monitoring to know what's really happening in your application. And if we care about like the CPU, what about the energy efficiency? And this is for, there are some like libraries, some tools you can use. For the Mac OS, they already have in the power metrics a tool that measure the actual power consumption, helping us optimize not just only the speed, but also like the sustainability. And this is what I'm going to show you next because we always talk about the CPU, the memory, the input output, but what about the energy? What about the power? Especially since unfortunately, our tech industry already consumes 7% of electricity, and that's only like going up, especially with the AI and how much energy does it consume. So how to measure it? Well, if you already, as I said, have in macOS, we have the parametrics and it's easy to use. You only have to run this command, the sudo parametrics minus sample the CPU power. Here we're telling it to run for like 1 second because 1000 milliseconds for 10 samples. The number here, it's the number of samples. So it's captured the CPU power consumption every second for like 10 times, helping us analyze energy usage in different scenarios. And you might want to ask yourself, well, I can like convert the CPU power by what into like energy. Well, it's simple. There is this formula. You will get the results of this command I told you before. This is what I'm saying by power and multiply it by how many hours your code have been running. So for example, here I tested before. I tried one of my old projects. I ran the command and I got like almost 3.776 watt. And then I tried to implement or modify some of the algorithms I used there to have more like the algorithms and try to implement just-in-time compilation with it. And I got this. So when I try to run my command to see how much energy does it consumes, how many or CPU power to be specifically being consumed, it dropped to 1.53 watts. Well, we can, for example, let's say I try to run both of those like application or projects for 1 hour, I will get energy like for my idle, my greener, it will be 1.53 watt per hour. And for my old, not efficient one, it will be 3.76 watt per hour. So if I just like said, okay, my code is already running, is already giving me the best results I want, I don't have to touch it. I'll be running on the high load and I will be increasing power by 146%. And imagine running that for like 20 hours per 7 day for 1 year, and how much my electricity bills will increase. And yes, that's something you can tell your boss too, because Green programming is not only about saving the energy, but also saving bills too. It will save a lot, especially when you are talking about electricity bills, while keeping the same application running with the same amount or even going on the scale. And now since we are talking about like the energy consumption and like when we measure the impact of it, how
Aisha, we
about
have, sorry to interrupt. We have another question, which I think is relevant to where you are now, which is how can you apply these settings for production apps? Like maybe it results in a slowdown of your application to kind of tweak these things. So is there a balance that you strike between power consumption and efficiency of your code in a production setting?
actually normally for the production application, if you're already like starting from scratch, is it's easier because you can add those tricks, the GVM to your like to the servers with scripts like as a default or your application. But for running application, you need to stop it and restart this again while adding those scripts.
Got it. All right. Very good. Thank you. Carry on.
Thank you. So as I mentioned, as I said before, normally we're talking right now about energy consumption. Third strategy that's related to this one is we need to reduce that because yes, we got right now to know the amount of energy our application been like using. It's time to reduce it. And by reducing, it's always about like three things you need to focus on. It's about energy efficiency, minimizing the input-output operation, and reducing the idle time and power usage, like to have more efficient application. So let's see that in details. For example, when we're talking about the memory, because as we know, excessive memory usage leads to unnecessary CPU cycle and wasted energy. And to avoid that, sometimes you don't need to do like complex things. You don't need to create something that's really hard. You need to start simple. Some simple things you do can really like save you a lot of memory. For example, let's say we want to go to have a list with random access. We need to go with array list instead of linked list to avoid like linked list pointer overhead. And let's say we want to have some like want to build a string by adding many characters instead of relying on the traditional string concatenations like the plus operation inside the loop, etc. We need simply to use string builder. Why? Because string are objects that are immutable. So each time you add a character to a new string, you are creating a new object. Let's say you in a loop you add 1 million of like character, and that means you are created 1 million objects, and that means the garbage collection needs to deal with cleaning up 1 million objects after this. That's 1 million long position. Whatever it's small, if it's multiplied by 1 million, it will become big. And this is why, like when you use string builder, which is our mutable object, whatever you, how much like 1 million, 10 million character you add to that string builder, it will keep like the same one object to deal with. So by the end, garbage collection will just clean one object. And also like for treat safe operation, it's better to use concurrent hash map. It performs better than the synchronized map to avoid like the waiting time. So this is why like memory optimization by doing something really simple like that can reduce the GC pressure, the CPU usage, and energy waste. But as I said, memory isn't the only culprit. What if like the real issue is maybe the input output operation because heavy, those heavy operations drain power too. This is why it's better like to use the buffer input-output stream, and asynchronous input-output operation to reduce blocking and waiting time. Because waiting time is always the issue that we have in our application. Because traditional streams block threads, but the NIO buffer and the channel reduced waiting time. And instead of, as I said, waiting for file operation, we let them execute in the background. And also, why not like use this is one of the features that I really like, the completable feature, because it helps execute multiple input output tasks in parallel without keeping the CPU thread idle. And this is why like reducing those operation bottlenecks makes our application faster and more energy efficient. But even when our application isn't actively working, it can still like waste time. And this is what we're going to see here by reducing the idle time. And this is where we need to implement techniques like thread pooling to manage resource efficiently. Like there are many, and you can drop like any thread pooling you have been using, techniques you have been implementing in your application. Because I'm going to mention like two or three, but there are many, and I would love to learn more if I could use it in, that I didn't know before. So for me, mainly I'm using like the fork join pool, which distributes work across available CPU cores efficiently, reducing the wasted cycle. And there is my favorite one, which is actually this is my favorite new feature since Java like 17. It was like preview, I think, which is the structured concurrency. It prevents unnecessary thread waiting, like keeping execution streamlined. And it's one of my, actually, I prefer structured concurrency better than the virtual thread because it doesn't have that waiting time and always keeping execution streamlined. And also, please try to optimize recursive calls instead of just those deep complex recursion. We're structured the logic to minimize redundant computations. And this is why, like, by optimizing the memory input in idle time, reduce power consumption, improving performance, and making our Java application more sustainable. And the last and not least, there is the latest Java strategy I'm going to talk about, and the most important one. Well, can you guess about this? Like what I'm going to talk about, or what strategy do you think I didn't mention? And this is what to really define. I'm going to give you like a hand. This is what define everything in our codes. Please drop in comment like what strategy, the most important one, or the one that I forgot to mention. Do you think it's really important to be to be talked about? Okay, virtual trade. Actually, as I mentioned before, it's depending always on your like code because traditional trades were in Java had the issue like it doesn't work with parallel that much. You need really a complex algorithm to do so, and like with you need to do it with the waiting time and so on. But if we're only dealing with the simple, like a simple algorithm that will calculate some for example, Fibonacci, we don't need to use virtual tree because virtual tree, actually, I'm going to look for a resource I saw. It's showing that the virtual tree like take work, the work that the time that it takes for make the work done, it's only, if I remember, 2.5%, and the wasting time it was like this one, and I don't remember really, but it was like a really big number of the waiting time. And this is why virtual trades are good, but we were talking about complex when we really need parallel. If we don't need that, don't use it.
Got it. We got a couple more guesses here, Aicha, on what you're speaking to. One is records, another is streams.
Oh, actually, you're talking streams, records. It's more general things that we do, like we use records, streams on that. It's close a bit, but actually I like records too. It's greener than just using. For example, I like to use records when I have let's say I have a method with the 7 parameter. Instead of writing 7 parameter for the method and call it every time, I use the record that have the 7 elements of it and call only one record per one method. And that's help too for saving energy.
Got it. We
Primitive.
got
Uh,
yeah.
Actually, primitives are good too because it's, and no, as I said before, primitives, it helps to be, they are greener choice too because it gets saved on the stack, not on the heap. And yeah, so actually the most important thing in the last one is algorithms, because algorithms, they are the core for the greener Java application. They define how efficient we process data, like search for information or compress file. A bad choice or a bad algorithm can lead to like bottlenecks, high CPU usage, and wasted energy. But something you already mentioned before in the comment, and like you already said this implicitly, is that we have a challenge, because it's not just about the speed, it's about finding the right balance between performance and sustainability. Because even the fastest algorithm can be wasteful if it's drained too much resources, and we cannot keep like a lowest application running on production just because it's like it takes only a few resources. It's only like the big challenge about sustainability is finding this balance. Let's see an example of this. Let's say we have like a massive list of data sets. We want to sort it. Our team said, okay, let's go for quick sort because it's quick and it was the best choice. But here is an issue. Quicksort performs unnecessary swaps in comparison when the dataset is nearly sorted, causing the CPU spikes and wasting energy. Let's say we have 1 million datasets with only 3 or 4 elements that's not in the right order. So if we use quicksort, we will end up like having million of swaps, comparison, and wasting many resources. Well, and this is like the challenge that we need to pay attention to it. So the solution, we need to switch to time sort. Why? Because time sort algorithm detects if it's nearly sorted data set and optimize the sorting dynamically, like only getting it to go directly to the unsorted one, making the necessary swaps in comparison. That by the end we will have reducing the CPU cycles and the memory access overhead. So the result, we have fewer computational, lower power consumption, and much greener algorithms. And this small switch makes a huge difference, as you can select the results here. And this is why when we implement algorithms, we need always to have like a clear idea on what we need, and like the input we're going to have, if there is any special case, or if there is a general case that we will end up like for the input or for the output too. So this is why like algorithms are not, we need not only consider if they are faster, but also if they are greener too. And as I said, always we can make a cleaner code into a greener one, because cleaner is already we can say like the perfect road for greener. And right now, since we have like we cleaned our application, we tuned our garbage collection, we have our Java GVM tuned. We said, let's say we choose the right like algorithms. It's time to stop the GVM strategies and go beyond that to the cloud, because Cloud can help us take this further dynamically, efficiently, and sustainability. Preferring the cloud-based solution can also contribute to the green programming in a better way because, as you know, the cloud providers often operate energy-efficient data centers and offer scalable resources that can be managed more efficiently than the traditional one. And before going that, if you have any question regarding the GVM or the Java strategies I mentioned before, you can ask now since we're talking about it before going into the cloud.
We have a question from earlier, Aicha, about reactive programming. Is it inherently suitable for writing greener code, or does it depend?
Actually, reactive programming is a really good approach because you get work done and it's always being always reactive, you're always making sure that you only use whatever only what's needed. And that's for the traditional one when you have all the input, the output without always making it going on.
Great, thank you.
Okay, so as I said, we're always talking about the Java programming, we talk about the objects, and reactive programming can help too because instead of just imperative one, the static one, it could help because it's always changed. It's always we can still sorry. Do you hear me right now?
Yep, we can hear you.
Okay, because I lost it for a second. Yes. As I said before, normally for the question of reactive programming, it's really a good because normally the traditional one, it's always, you can call it not dynamically changing, but for the reactive, it depends on the data, it depends on the input, and that's something we need to pay attention to it in every sort. Because green programming, it's always about creating an application that can have, okay, thank you, that can have, that can be dynamically reactive with you. Whenever if you change data, it will change the behavior. Not only you need to do the same behavior for the same data, even if it's different cases. And now let's go into the cloud. As I mentioned before, normally, the, as I said, when we go into the cloud, we get a scalable resource that can be managed more efficiently than traditional one. And this is where instead of just stuck in with the traditional hardware where we cannot adjust the CPU and memory, we can right now control that amount too. And this flexibility can help us a lot. It can lead to significant cost and energy saving for your application. And as I said before, this is one of the things you can tell your stakeholders because implementing green programming is not the hard step to do it. It's about convincing people to let you do it, especially your boss. This is why I'm telling you, best thing you can convince someone is that green programming, it will keep your application running, but with less builds. And since we're talking about the cloud, what's a better way than using Kubernetes for resource management? And when we talk about Kubernetes, we talk about autoscaling, especially with horizontal pod autoscaler, HPE, that's dynamically adjusted based on the load. That means it's telling you, just leave me alone. I know what's going to do. If there is a lot of traffic, I'm going to add more pods. If the things are quiet, I'm going to reduce the number of pods. That helps balance the resource usage and the cost efficiently. So how we can do it with its simple thing. You can only implement this script You need to specify the kind of horizontal pod autoscaler. And then for the spec, you need to tell like how minimum number of pods you want and the maximum number. And disclaimer, please, the minimum you need to put is 1, because if you put 0, there is a risk that your application will or your cluster will shut down. And the other important things is the metrics. You need to specify the type of resources that you need to target. You need to that each PA need to observe. For our example here, it's the CPU. I'm telling them that if our application or our cluster CPU usage or our application is over 30%, you need to create another pod. For example, here we already deployed our green Java application. And as you can see, it's already consuming a lot of CPU here. And when we apply the HPA, we got, and when we monitor it, and already we got this. So since it's already like past 30%, we have two Republica. And as a result, we got this. So we got right now two Republica instead of 1. But the good thing for the CPU, it dropped. It's almost like less in total than this one here. It's almost like 145, I think. Or it's like, it will be 150 instead of 200 plus things here. And this is why like HPA, it's really important if you are using Kubernetes and if you are going on the scale. And if you want to have like the perfect autoscaling, let's introduce the VPA, because HPA making sure that you have the right amount. Let's say, for example, you have a pit crew. HPA will make sure that you have the right number of pit crews that your team need during that race. But for the VPA, it will make sure that each team crew have the right amount of resources. That means for each pod, it needs to have the correct one, like to prevent over provisioning and under provisioning, not having less resources or not having more resources that it's needed. And also something to to remember, please reduce, reuse, recycle your containers. You always hear reuse, recycle your garbage, but you can use it for your container too. Please stop doing all like, I need a backup for my backup. I don't know what's going to happen in the future. Because if you use like the auto scaling for HPA and VPA, you don't need to think like about worst case scenario where your cluster is shutting down or your pod is over provisioning or under provisioning, because auto scaling, and when you implement it right, it will prevent this. And for the VPA, it's simple. You only need to like run some script like this with specifying always the kind, the virtual pod autoscaler. And here is what you need to do. For update policy, you need in the update mode, you need to set to auto. That means that automatically Kubernetes will make sure that each pod have the right amount of resources. And when you run, like here, Kubernetes describe VPA, you will get the recommendation here, like the minimum amount and the maximum amount each resources will need. For the CPU memory, it's the target, the uncapped, and the uncapped bound, everything needed here, you will see it. And now, like we get our application, we implement some strategies for Java application, we run it on the cloud, but we need to, or the sixth strategy and the final one is measuring and monitoring tool, but in more advanced way. This is here we're talking about tools that will help us see the overall changes, like impacts of our optimization. We don't need only to, okay, let's say I'm analyzing my resources, I'm reducing them, I deployed on the cloud, but I need to see if I really have a huge impact after this or not. When I'm talking about the impacts, I'm talking about electricity, the energy, and the most important thing, like the carbon. And this is why we have tools like Green Software Foundation's Carbon Aware SDK. It's a tool that helps like software developer to create carbon aware application. And there are many such as Dynatrace, which I love Dynatrace because it has like AI powered monitoring tools. It gives you metrics that you need. And also if you are more into like visualizing data, it has some metrics too, and something you can use. Every developer is already familiar with that are Prometheus in Grafana for like monitoring solution, for tracking application, metrics to see like if the performance is going like up, well, resources are a bit like reduced than before and so on. So like all these like Prometheus, Kubernetes, Java, the other tools, all those heroes can like help us together to have more greener and protect the environment from inefficient code. And now let's see some like let's go into the real world to see the real impact of some initiatives, projects that have been implementing green programming. Let's talk first, or I'll try to make it short. It's my favorite one is the green tech software solution because this company, from the start, it focused on energy efficient software and always like for environmental monitoring of their application. That means they use like they implement mini green strategies, they like optimize algorithms, cut down like energy composition, like when they say greener algorithms with less computational complexity, and always making sure they use some cloud-based solutions to monitor their resources to instead of sticking with traditional one. And as a result, like results, they achieved 40% reduction of energy consumption and like they decreased carbon footprint. And as a result, or this is the true win because that energy, 40%, it could it's enough actually to like energy and power 200 houses for 1 year. And imagine if every one of us tried to implement those strategies, how many houses we could like save energy to power for years or even a decades. And this is why it's time to call for action. Start more, implement green programming practices. I'm not telling you to go write your application from scratch or from zero, but even like the idea of if you already know where you can start or you already suspect that some parts of your projects are already draining power and you want to go check or measure it, you're already like doing a good steps because baby steps are better than zero steps. And remember, you need to educate and advocate. You need to raise awareness within your team and like your friends, your leaders, because a greener could base lower cost in both energy efficiency and like third thing, optimize and monitor. Apply best practices and track progress for continuous improvements. And finally, join the movement. Contribute to sustainability initiatives. Whatever we are like, right now you're already like joining the movement by attending this talk. So thank you all for, if you are watching it right now or later, you're already like helping the environment by having the time to invest to watch it, like read articles, attend conference. There you can also like join some communities. There are many of them. They are just not that much known. For example, the CNC, if you're using one of its products, they have like the tag environments green review group. You can Google that. It's a good because it shares tips. They have meetings. Also, like there are many right now essential products that have the focus on how on to improve the autoscaling for For the Java, there are some initiative about like having more advanced garbage collection that reduce power. For the GraalVM 2, the latest one, I remember, yes, the latest GraalVM version, it used less power during the first start or even during the execution time. I saw, you can check Alina's talk on JCon. Yes, she talked about that during one of its slides. So this is why I'm telling you, like, teamwork make the green work. Advocate, learn, start, or the first thing is start practicing green work, because even if it will not impact you, it will impact your kids, it will impact the future too. And here is a fun fact to consider. If every Java developer starts optimizing their code for energy efficiency, we could reduce global energy consumption by equivalent of removing between 20.7 to 30.8 million cars per road. And if you think that I'm exaggerating, well, actually, because normally, like, uh, we can say that global data centers consumes hundreds of terawatts annually, and even 10% efficiency improvement could save around like 24 to 34 terawatts. That's roughly equivalent to energy consumption of about like 2.7 to 3.8 million. And this is the impact that we're looking for. And this is where I'm going to say thank you all for your attention and participating today. And if you have any question, please say it, and let's make our code cleaner and the planet greener.
Thank you so much, Aisha. We have one more question here, which I think is worth taking a look at. What about updating to the latest Java version, the latest JVM, or the latest framework in terms of efficiencies? Are there any kind of stats on, the difference between 17 and 21, say, in terms of just, being greener because it runs more efficient or because they eliminated some waste or anything like that?
Uh, I will look for resources exactly because I cannot say something I'm not sure about. But as I mentioned before, for GraalVM, the latest version, it was there is statistics showing that it's more greener than this. For the execution time, it's less. And also, what I know, it's about the garbage collection. It's the latest one. It's more greener because right now they're paying attention to the impact of our codes. It's always about reducing the energy consumption, lowering the time. Especially right now, the most difficult thing we are dealing with is the waiting time. Like the idle time our application have been that doesn't do anything but still like draining power. And that's something the Java community, the Java ecosystem are really paying attention to it.
Oh, well, thank you so much. I have to admit, I really have not spent a lot of time up until now thinking about energy impact. I think for developers, it's often about efficiency and speed and start times and, bottlenecks and things like that. But it does seem like there's a correlation that you can make, like in the idea of garbage collection. If you make garbage collection more efficient, that's going to translate to better energy consumption anyway. So there's an alignment there, it seems like. So you really gave a great education today. Thank you so much.
Thank you, and thanks to everyone who's gonna watch this because at least learning the impacts of our code is better than none. Because normally for me, like the fun story when I first heard about the numbers someone said about like how much energy our industry consumes, the carbon emission too, I thought he was kidding or just exaggerating until I found actually it was worse than this. And this is why I start giving talks about this, writing like articles, and there is a barcode if you want to read more about this. As I mentioned, normally because we only keeping our eyes on our screen, on our code, IDEO, and so on, we don't see beyond that. we can't talk about the financial like impact because if we are making real profit of that, if we are creating application, installing it that much, but we never consider the environmental impact of that. As I mentioned, normally we are talking about recycling our garbage, but we forgot about the virtual too. This is why I start to like share ideas, share articles, raise awareness, because we need to protect the planet because we are living on it and it will impact us sooner or later.
Well, I'm definitely going to be stealing the teamwork makes the green work tagline. I really like that one. And I want to thank everybody for all the questions today. It was a really lively session. That's all the time we have, but you can definitely drop questions, continue to drop questions in Slack. Huge thanks to Aicha, and it was really great to be your host on this month's VJUG session. Back to you.
Actually, thank you. Actually, there is I forgot to say, normally, like clean code can make our application maintainable, but green code can make our application sustainable.
I love that one too. I will steal that as well.
I feel like we need to make a bunch of T-shirts with all of these. Green work, teamwork makes the green work. So many slogans. Amazing. Well, thank you both of you. Micah, absolutely epic hosting as usual. And Aicha, that session was amazing. As Micah said, if anyone has any questions still or is watching this, not during the live stream, if you pop over to our virtual Java user group Slack, you can ask more questions. Let me get that up on the screen. So join us on Slack. But thank you so much to both our speaker and our host, Micah. Now, for everyone that's still around, just to let you know, we will not be doing a session next month. So our July session, I want to go on holiday. We're going to have a little, let's do a summer break for everyone in the Northern Hemisphere. And everyone in the Southern Hemisphere, I'm assuming it's getting a little bit warmer. And hopefully you can take a break too over July. And we'll be back in August with some more amazing sessions. But please, if there's anyone or anything you'd like to hear about, drop us either an email at virtualjug@gmail.com or get us on Slack or on most of the social platforms and let us know who do you want to hear from, what do you want to hear about. This community is for you. And if you're not seeing sessions at your local Java user group or you're not managing to get to any conferences or you just have specific things you want to see, just let us know. We'll find the speaker, we'll find the content, and we will put it on for you. And again, a reminder, if you have any local user groups doing cool things, we do want to live stream their events. Super easy. We cover all the admin and logistics on doing it, and it means that people get to see the sessions happening in your town or the talks that you're doing globally, because we all have something to share. I'd love to think that the 100 people watching this session are the only ones that need to know about green coding, but they're not. There's thousands of people that need to hear about this session and the other sessions happening around the world. But as I said, that's enough from me for now. And we will see you again in August with some more amazing sessions. But yeah, keep an eye on our meetup for our next installment. And thank you all of you who watched. But bye for now.